Hi everyone, I'm Joseph Parvizi, and I'm here to explain how we design Clarity, what it is intended to do, and how it is meant to empower clinicians at the bedside. It's an AI-based algorithm that cuts the last 5 minutes of EEG into 10-second segments. It has been taught to recognize at least 52 features of the signal to be associated with seizures. And then the algorithm uses these features to determine if any of these bins contains seizure. These seizure-no seizure outputs will then be averaged over a 5-minute long window of EEG. This output will be plotted over time as the value for seizure burden. So percentage of bins containing seizure to the best of machine's capability. Based on all those 52 features it has learned to associate with seizures. Every 10 seconds, this window moves forward and the value is updated. So every 10 seconds, there will be a value for the percentage of bins containing seizure. In other words, over time, one will see a trend going up or down in terms of percentage of the last 5 minutes containing seizure or no seizure. If it's 0%, it means to the best of machine's ability, almost none of these bins contained seizure. If you click on seizure burden, you will see this plot and you will see the number that basically represents what the percentage of seizure burden is at that time for the last 5 minutes.
Here I'm going to go over the main findings of this validation study. In this table, you see how humans and how Ceribell Clarity AI algorithm performances are compared. In this validation study, 353 EEGs were reviewed by several EEG experts who made their assessment, and based on the consensus of these EEG readers, they were labeled either as non-convulsive status epilepticus, NCSE, focal seizures less than 5 minutes, or just seizure, or highly epileptiform patterns, or the rest, i.e. normal, slow, rhythmic delta activity, and so on. And then, once the machine interpreted all these 353 EEGs, these numbers were obtained. The machine thought 33 of them are in status epilepticus, 141 of them had some sort of seizure burden but less than 90%, they were not clean, but 179 of them were 0% seizure burden. What excites me about this is actually twofold. One is that all those that were labeled as status epilepticus were captured by the machine. So 100% sensitivity for detecting status epilepticus. And another number which excites me is 157, meaning that a large proportion of those EEGs were in fact either diffusely slow or just benignly abnormal. What that means is that of 353 EEGs, 179 times the reader may actually benefit from longer sleep during the night and not get a page immediately to provide a stat EEG read. If that's the case, 2 of 179 times a seizure might be missed. These seizures, it's important to note, were not status epilepticus type, so they were not very prolonged. Of those 33 alerts, 9 were status epilepticus, a good proportion were highly epileptiform patterns, and few were normal or slow or rhythmic delta activity. So you will see that this AI will triage the cases into highly abnormal or EEGs can wait for non-stat read. So to present the highlights of this validation study, if you go with the threshold of 90% or higher, you will have 100% sensitivity for status epilepticus. There will be definitely overcalls, but these overcalls will be for the most part highly epileptiform patterns that may benefit from a dose of anti-seizure medications anyway. And if it is less than 10%, and especially if it is 0%, then clearly it had a very good negative predictive value, meaning that it is highly unlikely that the patient is having prolonged seizures. Lastly, I'd like to go over the workflow in some of these hospitals where the Clarity has been used. It's important to note that any AI algorithm, like any other tool in medicine, provides an additional clinical data point. It's the accumulation of these data points in the context of clinical suspicion that will determine the path to treatment. If the clinical suspicion is very high, currently every patient is treated. But with the AI, you will treat only the ones that are over 90%, and you will ask the EEG expert for stat read. But if the suspicion is high and the AI shows less than 10%, these are the cases where overaggressive treatment will be preventable. And the EEG expert can read these non-stat. If the clinical suspicion is low, but the AI says over 90%, these are the cases that might be a non-convulsive status type and need to be verified and confirmed as soon as possible. If the neurologist or the expert is not available during after hours, one might argue that these cases may benefit from empiric treatment with an anti-seizure medication. Overall, how this is going to help your hospital is by shortening the time to needle in those cases with non-convulsive status epilepticus, and it will certainly eliminate many cases of overaggressive treatment such as intubation, paralysis, and ICU admissions. I hope that this presentation was useful. If you have any comments or any questions, you can always reach me at joseph@ceribell.com.